The Metabolic Price of Cognition, the Brain's Staggering Energy Demand, researched by Sachin Karnik, The Angel Wing LLC. Introduction. The human brain is widely regarded as the most complex structure in the known universe, a biological masterpiece capable of consciousness, creativity, and intricate regulation of physiological processes. However, this functional sophistication comes at a steep physiological price. As illustrated in the research presentation, The Brain's Staggering Metabolic Demand, the brain is not merely the seat of intelligence, but also the body's most metabolically expensive organ. Understanding the disparity between the brain's physical mass and its energy consumption provides critical insight into human biology, highlighting a delicate homeostatic balance that, when disrupted by factors such as chronic stress, can lead to significant mental and metabolic disorders. The disproportionate energy consumer. The most striking feature of cerebral metabolism is the sheer disproportion between the brain's size and its fuel requirements. Anatomically, the human brain accounts for approximately 2% of total body weight. In a system where energy resources are often conserved, one might expect an organ of such modest physical stature to require a commensurate portion of the body's energy budget. However, the data reveals a stark contrast. The brain consumes approximately 20% of the body's total energy. This tenfold discrepancy between mass and metabolic consumption identifies the brain as the body's primary energy sink. The vast majority of this energy is supplied in the form of glucose, underscoring the brain's reliance on a consistent and high-quality fuel source. This intense metabolic activity is not merely a byproduct of existence, but a requirement for the continuous neural firing and signal processing that defines human life. The necessity of homeostasis. Given the stringent energy dependency, the brain operates under a mandate of precise physiological regulation. The slide emphasizes that the brain requires a highly harmonized homeostatic balance. Unlike muscle tissue, which has significant energy reserves and can tolerate fluctuations in fuel availability, the brain's high-performance nature demands a steady, uninterrupted supply of glucose and oxygen. This dependency suggests that the body's metabolic systems are prioritized to serve the brain, ensuring that this critical 20% energy quota is met regardless of the physiological cost to the rest of the body. The destabilizing impact of chronic stress, the reliance on such a delicate energetic balance, renders the brain vulnerable to external and internal pressures. The research highlights a critical vulnerability: chronic stress. While the brain is designed to manage acute stress through temporary physiological adjustments, chronic stress poses a unique threat that can jeopardize this balance. The disruption of this homeostatic equilibrium does more than merely fatigue the mind. It disrupts critical metabolic processes. This connection serves as a physiological bridge between psychological state and biological function. The research suggests a profound link between stress-related mental disorders and perturbations in energy metabolism. This implies that conditions often categorized strictly as mental health issues may be fundamentally rooted in, or exacerbated by, the failure of the brain's energy supply mechanisms under the weight of sustained stress. Conclusion. In summary, the human brain defines a biological paradox. It is physically minute, yet metabolically massive. It accounts for a fifth of the body's calorie consumption, while comprising only a 50th of its weight. This staggering metabolic demand necessitates a rigid homeostatic balance, a balance that is perilously susceptible to the ravages of chronic stress. By linking mental disorders to metabolic disruptions, the research by Sachin Karnik and the Angel Wing LLC illuminates the critical importance of protecting the brain's energy stability, suggesting that mental well-being is inextricably tied to metabolic health.